So for homework, you had to do some exact trig value stuff. I put the clip from the book up on my big campus, and we also had to do some angles of elevation and depression. I'm going to start with the book work. I just copy and pasted it into my file. So we had to do 3, 4, and 5. We had to do 8, 9, and 10. We also had to do 14, 18, and 34. Okay, so notice we're doing exact values for 30, 60, and 45. So right off the bat, I'm going to draw those two special triangles that we talked about in class. All right, I'll put them up here at the top. So I've got my 30, 60, and remember it goes 1, 2, 3. So 1, 2, square root of 3, and then for my 45, 45, it goes square root of 2, square root of 2, 2. Alright, and we've got right triangles, so I'm probably going to use SOHCAHTOA. Alright, you need to memorize these triangles. So, let's start with number 3. 3 is just the cosine of 30. Well, I come over here and I look at my 30, 60, 90 triangle. I'm at 30. Cosine is A over H. Adjacent over hypotenuse, it's just the square root of 3 over 2. Number 4, I'm still in that triangle. I want the sine of 30. So I look at 30, sine is opposite over hypotenuse, opposite over hypotenuse. It is going to be 1/2. For 5, I want the cosecant of 30. Remember, cosecant is the reciprocal of sine. So I really want the reciprocal of sine of 30, which I just found out in part 4. So 5 is just the reciprocal of 1/2, which is 2. Easy peasy. Now looking at number 8, I want the cosine of 60. I'm in the same triangle, but now I'm over here at my 60-degree angle, and 60 is adjacent over hypotenuse, so A over H, that's going to be 1/2. Number 9, I'm doing the secant of 60. Secant is the reciprocal of cosine, so I'm going to do the reciprocal of what I just found, and that is going to give me 2. Number 10 asks for the sine of 60. I'm over at 60 in my triangle. Sine is opposite over hypotenuse, so it is going to be the square root of 3 over 2. And then I had to do 14. 14 is the cosine of 45. So now I'm in my other special triangle, and I'm at 45. Cosine is A over H, adjacent over hypotenuse. So I'm going to get the square root of 2 over 2. And 18 asks me the tangent of 45 degrees. Tangent is opposite over adjacent. So that is going to give me the square root of 2 over the square root of 2, which just simplifies to 1. And then we had to do number 34. 34 says the sine of 45 plus the cosine of 60. So first, let's figure out what the sine of 45 is. Here's 45. The sine is going to be opposite over hypotenuse. So the sine of 45 is going to be the square root of 2 over 2 plus whatever the cosine of 60 was. The cosine of 60 here, 60 cosine is A over H, adjacent over hypotenuse. That's going to be 1/2. And I'm adding fractions. I need common denominators. It already has a common denominator. So this is just going to be the square root of 2 plus 1 over 2. Bingo, bango, we're done. All right, you cannot combine the square root of 2 and the 1, right? We can only combine radicals if they have the same radicand. 1 is not a radical, so that is that. On to angles of elevation and depression. I put each question on a separate page. I know that you could not fit it on this worksheet, so you should have done it on separate paper. So let's look. A monument stands on level ground. The angle of elevation of the top of the monument taken at a point 425 feet from the foot of the monument is 32 degrees. Find the height of the monument. So I will draw draw the Washington Monument. Why not? It's fair. Or rendition. So there's my monument. The angle of elevation of the top. So remember, elevate means I'm looking up. So I'm looking up to the top of the monument from 425 feet away. So I'm standing over here. I'm 425 feet away. And I'm looking up to the top of the monument. And when I look up, that's my angle of elevation, and that's 32 degrees. I want to find the height of the monument. And remember, we live in a perfect world, so this is a right angle. So now I've got a right triangle. I'm looking at this angle. I want the opposite side. I know the adjacent side. Remember SOHCAHTOA. Opposite and adjacent is tangent. So the tangent of 32 is going to give me opposite, which is x, over adjacent, which is 425. Alright, this is an equation, so we want to eliminate our denominator, so I can multiply both sides by 425. That cancels, but I also have to do it on this side. So 425 times the tangent of 32 is going to give me my x value. I want this to the nearest foot. You're going to punch this in your calculator. Make sure you are in degree mode. And if I look at my decimal, it's a 0.5, so I need to round up, so it is going to be 266 feet. Make sure you include your units. Units are very important, especially for science class. On to the next. A boy flying a kite lets out 150 feet of string that makes an angle of 64 degrees with the ground. Assuming that the string is straight, find to the nearest foot how high the kite is above the ground. So I'll draw my picture. Here's my boy. Here's my straight string. Here's my kite. And here's the ground. Guess I can draw it. Solid, there we go. Okay, so 150 feet of string. So this length right here is going to be 150. And my string is making an 84-degree angle with the ground. So this angle looks kind of weird. Is going to be 64 degrees. And I want to find out how high my kite is above the ground. So this is what I'm looking for right here, my height. So looking at, and of course, perfect world, right angle. So if I look at this, I've got my angle. I'm looking for the opposite side. I know the hypotenuse. I know what it is across from the right angle. So if I look at SOHCAHTOA, opposite hypotenuse, that means I'm using sine. So the sine of 64 is going to equal the opposite side over the hypotenuse. This is an equation. We eliminate denominators, so multiply both sides by 150. So 150 times the sine of 64 is going to be equal to x. And again, I'm rounding to the nearest foot. You put this in your calculator. Make sure that you are in degree mode. I'm at a 0.8, so I'm going to round up. So 135 feet is my x value. So my kite is 135 feet above the ground. On to the next. A 25-foot guy wire attached to the top of a pole makes an angle of 82 degrees with the ground. Find to the nearest foot the distance between the point where the guy wire meets the ground and the foot of the pole. Well, I don't really know what a guy wire is, but I'm assuming I've got this pole. I don't know why, but I made it red. And it's attached to the top, and it makes an angle with the ground. So I'm attached here, and there's my wire. And if here's my ground, I'm making a 62-degree angle. And my wire's 25 feet. So this is 25. And perfect world, there's my right angle. I want to find the distance between the point where the wire meets the ground and the foot of the pole. So I'm looking for this distance right here, the distance between where the wire meets the ground and the foot of the pole. So going back to SOHCAHTOA, I've got an angle. I know the adjacent side and the hypotenuse. I'm going to be using cosine. So the cosine of 62 is going to be equal to the adjacent side divided by the hypotenuse. This is an equation we eliminate. So multiply both sides by 25. 25 times the cosine of 62 is going to give me my x value. I'm rounding to the nearest foot. Make sure you are in degree mode. Cosine 62. I'm going to round up, so 12 feet. It is 12 feet away. Perfect. On to the next. We're almost done. Find to the nearest degree the angle of elevation of the sun when a tree 24 feet high casts a shadow 36 feet long. So here's my tree. Someone mentioned that my trees look like atom bombs. I'll put a little birdie in it. Maybe that'll make it better. I guess that's a bird. I don't know. So, and then I've got the sun. So the sun's up here. Okay, and the sun is beaming down on my tree, and I make a shadow that is 24 feet long. And I want to know the angle of elevation of the sun. So I'm looking up at the sun, and this is a perfect world, so I've got my right angle. So if you look, I've got this mini right triangle right here. Doop, doop, doop. And so I want to know my angle. Oh, and I forgot that I mixed this up. A tree is 24 feet. Sorry, my tree is 24 feet tall. And my shadow is 36. There we go. A tree 24 feet high casts a shadow that's 36 feet long. Oopsie daisy. And I want to know my angle. So this one's a little different. I'm finding an angle, not a length. But let's look. I've got my angle. I know the side opposite of it, and I know the side adjacent of it. So I'm going to be working with tangent. So the tangent of my angle is going to be equal to 24 divided by 36. And how do I undo tangent? I take the inverse tangent of both sides. Remember, a function and its inverse cancel each other out. So this is going to give me x, which is going to be equal to the inverse tangent of 24 over 36, which you can do in your calculator. Inverse tangent 24 divided by 36. Whoops. And we are going to the nearest degree, so I'm going to round up, and x is going to be equal to 34 degrees. On to number 5. A 40-foot ladder is leaning against the building. The foot of the ladder is 32 feet from the ground of the building. The foot of the ladder is 32 feet from the building. Sorry. Find to the nearest degree the angle that the ladder makes with the ground. So here's my building. Put a little door, people. Oops. I mean, I guess it could have a circular window. Alright, chimney. Anyways, so I've got my 40-foot ladder. So here's my ladder, and it's 40 feet long. And it's leaning against the building. The foot of the ladder is 32 feet from the building. So this distance right here is going to be 32. Perfect world. So there's my right angle. I want to find to the nearest degree the angle that the ladder makes with the ground. So here's the angle that I'm looking for. I know the adjacent side and the hypotenuse. Adjacent and hypotenuse is cosine. So the cosine of my angle is going to be equal to 32 over 40. I need to get rid of my cosine, so I'm going to take the inverse cosine of both sides. a function and its inverse cancel each other out. So I'm left with x is equal to the inverse cosine of 32 over 40, which you can put in your calculator. We're going to the nearest degree. Inverse cosine 32 divided by 40. I'm going to round up. X is going to be equal to 37 degrees. And last but certainly not least, a television tower is 100 feet high and an observer is 120 feet from the base of the tower. Find to the nearest degree the angle of elevation of the top of the tower from the point where the observer is standing. So, I don't know what a TV tower looks like. Put a little nub on the top. I have no idea. So this is 100 feet high, and there's some dude observing 120 feet away. So here's my person. He's 120 feet away. We want to find the angle of elevation of the top of the tower. I'm looking up to the top of the tower. So I want to know this angle because I'm looking up at the top of the tower. Perfect world, right angle. So if I look, I know the opposite side and the adjacent side. Opposite and adjacent is tangent. So the tangent of x is going to be equal to 150 over 120. Right, tangent is opposite over adjacent. I need to get rid of my tangent, so I just have x by itself. So I'll do the inverse tangent of both sides. So x is equal to the inverse tangent of 150 over 120. Pop that in your calculator. Inverse tangent 150 divided by 120. And that is going to give you, to the nearest degree, round down, x is equal to 51 degrees. Alright, that was it for your homework. Just a little recap, because we didn't actually do any angle of depressions. Okay, let's say, and this was part of your homework, but just bear with me. Let's do the exact same problem, but let's say I have my tower and my dude is still 150 feet, or I'm sorry, 120 feet away. This is still 150. If I told you that there's some other person hanging out in the tower, all right, he's at the top, maybe he works there, he's fixing something, and he looks down at the person who's on the ground. It's his friend, he's waving. Maybe his friend brought him lunch, I don't know. So if he looks down, down is an angle of depression. So my guy starting here, when he looks down at his friend, that's going to be this angle right here. Okay? Now if I wanted to find out the angle that this guy was looking down, I talked about this in class. Alright? This horizon where my guy was originally looking is parallel to the ground. So right now we've got alternate interior angles. So my angle of depression is going to be equal to my angle of elevation. So they're equal to the same thing. But if you're drawing your diagram, you should actually have both of those angles in there. But that's it. I'm done.